Welcome back, guys. Okay, so this time I have also added my camera. So from now on, all my streams will have me there because I've been testing this for a while because I didn't have a proper place to be and stream the entire thing. So now I have a proper setup. So I believe it should be fine. And yeah. So let's start this week. Where did we leave off last week? So in general, we were just trying to write the file system layer that's just going to give us some abstractions like inodes and directories and overall it's just going to allow us to manage a block of memory as some sort of file system, I would say. I don't know. But after that, we realized that writing that upper layer is just not enough. We also need a block layer, and the block layer will actually handle the raw access. That is because, as we see, ext4 is just full of blocks, and that's how we see it in memory too. That's it. So it's just full of blocks, and we have super block, and we have groups, and each groups can have their own inode table, inode bitmap, and then we have the data blocks, and we have multiple groups, and they all have the same representation, but super block is only in block number 0. And so this specialized block layer will only work on like just reading and writing blocks probably. So that's why we have the block read and block write call. And this abstraction will allow us to support different physical systems probably. I don't know. That way the virtual system layer can just rely on block write and block read for no matter what physical device you have. And actual physical layer support should be given by the driver, something like that. So this time we're just going to write the same layer, the block read and block write. Okay, so where do we get started? We have a to do, and it says before that parse dtb and gets the registry address and interrupt number. So yeah, so it's just that we have a Kemu setup, and it has to we are providing something called drive, and we created a X4 image, and we are going to support virtio. That's something that's done by the Kemu itself, so we don't have to worry about it. Now all we have to do is that we are providing a X4 image that we created, and now our upper layer is going to use it. But first of all, to use it, we need to know where Kemu has mapped this particular fucking image. So remember the first, I guess previously we were trying to read the actual physical RAM, total RAM of my setup, because in my case it's 4 GB. So to we can just simply hard code that thing. So in case if we change things here, it should automatically be present. So Kemu puts all this information into the DTB, and it's in X4000 range. So we can just parse that and get the information like this, and we can also get the information about where this file is getting mapped, because that is probably device mapped, something like that. But we still have to use a specific, it's not like memory map, because you could, if it's memory mapped, you could just read and write to that memory location. But here we have to use certain protocol, I would say, because we have to send requests and ask it to, let's say, write this block to that particular block, and we have to just poll so that we'll get the response back. Because as you know, CPU is separate from a physical device, and the actual physical thing has to go, and it has to be done, and it has to be committed, and it has to come back. So it's fully asynchronous, I guess. I don't know, but we are just gonna poll and we're gonna wait for it. So let's see. hmm So, and this was our previous DTB, and this implementation is just simply a little bit of hard coding, but we are still doing some parsing, because I guess somewhere there must be some documentation which I believe is not there. I don't know why, but in general, I guess we have structures. So once we say that it's a token, you can just move on to the next token, and if you want to go into the token, you just read the particular offset within the strings. So it's kind of like it has a structure that we can parse through, but it can also have dynamic strings inside it based on integers. And that's why we first go to a token begin, and then what we do, we're checking if it's memory, and then we set inside memory, and next time when we come here, we'll probably inside token prop, and inside token pop you can actually have the length of the string and the indices, so you can actually read the string index from the string structure plus the offset. That's what I meant by indexing, because we have two different structures. One is structured with finite lengths, and then we have the string location where you can just index and put variable outputs. And okay, and probably I'm just doing, after we check, just checking R and G, and then I'm just actually reading the bytes and getting the total. Okay, that's fine. Now how am I supposed to actually read the, wait, when I was doing this part, I had an article which was DTB or DTD parsing. Someone wrote a good article about it. I guess they wrote it in Rust, so let's see. Rust. I don't know, but I remember using an article, and probably then let's try ttp dot. Not sure, but there was an article, and I was looking at the actual token structure based on that. But that was a long time ago. When was my last commit for this? Okay, I don't have my commit history here. Yeah, but this was like a really long time ago, so I don't really fucking remember any damn thing. Okay, one thing we could do is we could probably what? Okay. Okay, let's just try this approach. Um, and DTD should have memory locations. Camel drive. Device tree properties. Yeah, probably. So this is how in general things will be, because we'll have a label, and we'll have a register, and we'll have a interrupt number. Yeah, we'll have a label, and we'll have a register number. This is how it's going to be, but this is not what I want. This is not what I want. What do I want? I need to parse drives and get the register number. DDD. Camo. Register. Parsing. Oh, interesting. Okay, we have node begin, node end, and node prop. And we have strings. So in our case, we have to look for the string. What's drive? Probably. I think so. Let's just keep this as it is, because looks like we'll be using this part, because we already have that parsing. That is a for loop that's just going through all the tokens, and based on the current token we do certain stuff. Now my question is, what am I looking to read in this? That would be my question. And get a token, and we check if it's a token begin. If it's a token begin, we get into it. Else we just keep moving. Okay. In that case, now device tree device tree structure for external drives in Kernel. Let's see. Looks like we could just look for all the options with device tree in Camo. I simply want to know what will be the token name, nothing much. And where do we use get total RAM actually? We use it. Okay, we use it in the start, so we don't have print. We can't print the tokens. So we'll have to think about something else. Last time I remember somehow I found the name, but I didn't write it down, so I'm not sure. What was the node name I'm looking for here? Because we just have to add a name here and set that we are inside the node and get the values in the token prop. And it's as simple as that, but I don't fucking know the name that we have to search in this. What about let's see. Did not fucking copy. About this, or will I see this in GTD? Minus so automatically generates a tree, and it's going to appear as which MIMO nodes. Okay, so it's just going to have which IO MIMO. So wait, it's token begin, right? Would be which IO? Okay, So we have to look for every MMIO, whatever that means. I guess memory mapped IO. Okay, so let's do that. Let's take this whole fucking damn thing and copy it and paste it, and what do I put here? Let's say get drive info. Okay, and it should return two things. It should return, and so let's just pass memory address. Let's just pass actual array so we can just return things there. Char star. What do we need? We need a number and MIMO, and we need an interrupt. I guess we don't need this. We only need the register and the interrupt. So let's just have UN64 star results. And it's not going to return anything, right? And we take the DTB base, we parse it, and I think we have the two things, that is the DTT structure where we actually do the parsing, and we have the DTD strings. Those are two just offsets, and we can directly use the DTB base plus the offset value to reach that particular thing, and then we can just iterate over it until we are done with actually parsing. That is probably when we reach token end. Also here we could just change these inputs to say which IO MIMO. So let's just say VAR VI R, and it's 3, and it's 2. So let's go through every which IO nodes, and we can say this as was it inside which IO. So that should be good. Let's just yank it and paste it. Shit. Why is my yank not fucking working? Okay, so is it still recording? Fine. Okay. So we have the same conditions. If we are inside the which IO, we would just get var as the initial string. So that should be good. Now once we are inside that, we'll have to go into the token prop and read the length. Probably this will be a property, this will be a property, and this will be a property. I believe so. I'm not sure. Also, if if we are inside which.io and string equal to R and G. Okay, maybe it's this fields. So we have multiple tokens. We are reading the length. And we are checking the string offsets, and we get the string, and we check if it's a reg, if it's a fucking register. What do we do? I don't know. What the fuck am I doing here? It's just uint32 I values and imax and I++. And we have read 32 bits and +4. But what the fuck? What the fuck is this? Okay, maybe this is just because we want a 32-bit integer. No, we want a 64-bit integer and we can only read 32 bits. That's why maybe we are reading it twice and then shifting it into a single 64-bit value, probably. And we get an add and we get a size. Okay. We get the register start, and we get the size. I think this should exactly work as the previous one. And here, in case of returning the total, we could just return the ads. That's the address. Because we just want the address. Maybe we could potentially wait a minute. We're inside the which.io and it is a register, and we take the max. If it's less than max, we keep what is max? Oh fucking hell. What the fuck is max? Okay, max is here. Okay, we max is just length divided by 16. Okay, because we are reading it as 32-bit. Then why the fuck am I dividing it by 16? Okay, so 4 32-bit entries is equal to 16 bytes. Thank God I wrote this fucking thing. If not, I would be fucking my brains off now. Whatever. So right now we have the max value, so we could just iterate over all these 4 values, and wait, I have 4. What is I? Why the fuck am I iterating it through it 4 times? Because if I know that it is 4 32-bit entries and it's of 16 bytes, first 16 bytes would be this, and the second 16 bytes, third 16 bytes, and the fourth 16 bytes. What the fuck am I doing here? I don't know why I have to iterate. This should be fine. I don't have to iterate because when I read the first 32 bits, I could just increment it by 4 and read the next 32 bits, increment it by 4, read the next 32 bits, increment by 4, read the next 32 bits, increment it by 4, and get the total thing. What the fuck is... Maybe length will be just I remember it because the RAM information can somehow have multiple similar entries. That's why we need max, and then we can have the total. But in this particular case, there is always going to be just one entry. There isn't going to be multiple entries. So we can just we can leave it as it is because currently I guess the length value will be just 16, so there will be only one iteration. I believe so. I think it should be fine. Well, let's test it. Let's just put event. I think that's overkill. Let's just remove it. Let's just remove it and do it once, and as soon as we find it, we could just return. We can return here, but let's just update the results. Result of 0 would be our add address, and result of 1 would be our size. Okay, now we have both the fucking things, and let's just put inside which equals 0, and the rest of the stuff should just be fine, just be returns. I think case would just fall back to default and return, or we don't even have to. It's just defaults. Okay. That should be good. Do we have to read the interrupt number? Maybe we would like to read the interrupt number too. Fuck it. How do we do that? Then I can't just simply return here. Maybe I'll return after I find the interrupts. It's possible. There's nothing wrong in that. Okay. I just have to add another if condition saying else if inside which IO and string of 0 is what in I and string of 1 to 3. I mean, I can't simply assume that it will always have this in this index, but if I am inside which IO, I should probably have this, so this should not just overflow. So this will be the guard. What if there's a which IO that does not have an interrupt? Then this would try to access an invalid memory. I don't know. Maybe we could deal with that later. Let's just put string of 1 equal to n and string of 2 equals to it's t, and we are good to go. If we are inside the which IO and if we are inside and we have int as the string, then we could just say, and first of all, what are these 3 numbers? Why does it have 3 numbers? What are those values? Okay, so it's an interrupt type, shared peripheral interrupt or private peripheral interrupt. I don't know what the fuck that means. And then we have the interrupt number that we want to add to our fucking, what is it? We do have an interrupt handler. Yeah, we'll probably have to add it here. Okay. And trigger flags. Okay. But how the fuck do I use this? Where do I use this? I don't know. Because that looks like something we would do in what? There's the I don't fucking remember the name. I guess it's what is it? It's a language. Fuck me. Yeah, it's Verilog because almost every interface within Verilog it's in rising edge or falling edge. Yeah, I guess it's in rising edge because I almost remember always writing it as sparse edge. Okay. Maybe we don't even have to read this. We'll just read these 2 values. Okay, so if we're in this, we still have to do the same logic of checking the max values and stuff. because we have to read till that point. Okay, again, I think I should not return here because I want to keep going. In my previous case, I could return, but not here. Here, I would just say continue. And let's put continue here. And we are again reading the same thing. But in this case, we'll only need to read 3 32-bit integers. And we don't need the final value. And all those 3. Wait. And all those 3 values are just 32-bit integers. It's not 64, so I can simply just read the values and leave it as it is. I think so. I read this, increment it, I read this, increment it, read this and increment it. And I don't need this logic because they are just 32-bit values. Okay, but in that case, I need to fucking move them to 64 bits. How do I do that? How do I fucking do that? Maybe I can put one thing as just size 1 is just 0. Size 2 as 0. Because that's the front part and this is the back part because we read it from back to front. So here, so we read from the beginning to the end. So I can just set size 2 as just 0. And I think I should do the same for all the values. It should be h1 time h1 and h2, and then we can have this should be, what is it, the interrupt number, so it's num1, and we have events 32 num2, which is just 0, and we have what is this, type, I guess, type 2 type 1. And let's type 2, and let's just put 0 here. Now we can just convert all of them into H would be H2 and H1. That's it. Let's just copy paste it and kill it and put type here. What the fuck? And put type 2, type 3, type 1. And it should be num2 and it's num1. Looks good. Okay, we have edge type and what's this num. Okay, we have all the 3 fucking values. What else do we do? And in case we are inside this, we should also say it's the 3rd and 4th and 5th should be edge type. No, let's put type num and edge. So we have 5 return values. We'll get the registry and the size, and we will also give the edge type and number. Okay, I think that should be good. Now we have to try this out. Nothing much. And one thing I'm going to do now is that I'm not going to call this from the what is that? We're not going to call this from, I don't know what am I supposed to say. Yeah, I'm not supposed to call it from start because I can't deal with any errors there. I'll have to manually fucking go through them. It's just so fucking annoying. So let's just add the page table entries and call it from, what's that? I'll just call it from kmain. So let's see. We yank it and we move to kmain. We paste it and we fucking remove this. Put text in here. And put a semicolon here. Now we are good to go. And let's just call it in the beginning of the kmalloc. First of all, I need UN64 star what is it, results, let's just say drive info. But if it has multiple drives, then we'll probably fucking overwrite it, but then we'll think about it later. Let's just first of all figure this out. And we call get drive info, and we need to pass and results drive info results equal to, and we don't need anything because we are going to pass it as reference pointers. And we have to call un star malloc. Let's just allocate some memory. I can just put size of UN64 times 5. Okay. Because I only need 5 inputs, so I'll just create an UN64 block of 5 blocks. I can just put that as drive info. Now all I have to do is enable add table entries for 4000, because that 4000 block is not in my range, and I'll probably have to write, let's see, where is my MMU? Maybe I'll just simply add this here. Where is it? I'll add an entry for, say, okay, I'll add an entry for, let's just say, find DTD base. I guess I already have DTB base somewhere. Wait. Okay, I have it here, but it's a C fucking file, so I think I can't do that. I was thinking maybe we could just include it. Okay, I can simply set it to that, and I have DTB base. I can set it to virtual DTB base. Which DTB base should be Jirex? Yep. Can I use 3000? If I use, I don't know, if I use this, I'll fuck up something else. I don't remember all those locations that I used previously. Maybe I'll just use 5. And if we ever get reach this through dynamic allocation, will have to move this around. Okay, then I can just say yes. Oh, fuck me. Yeah, here it is. Let's copy this, paste it again. Fuck. Paste it again and say for DTB, and we want virtual, calculate virtual for DTD base and make block for, was it what's my block? DTB block, DTB base. I want to allocate that to this inside my L2 table. Oh fuck me. If I add this inside my L2 table, will this fuck up something else? No, they all have separate tables, so maybe it will just fucking work. But after I switch there, will I be able to use this? It has stack, so I think we should be able to use it. Okay, let's try. We just added the DTB block, and because it's just to map some 0x8x value to 0x4000, because that's where DTB is. I don't know, we don't have to do anything else, because in K-main all we are doing is just allocate some space and call this, because when we call this, we'll actually do some actual dereferencing of this D2B base, so we need page tables for that. So I think that should be fine. Okay, what else? I guess that's it. Let's just try to run it then. Run it and see what the fuck we have made. What? Okay, I recently restarted my probably that's why. I fucking forgot my password. You did not agree to type agree. Okay. I didn't fucking agree, but still. Okay, now we have fucking some errors. Okay, that's because we added that file. We can't deal with that now, so let's just remove that. First of all, why did I add it to my build? Let's just remove that from my build. As it's okay, there's no file here, then why the fuck did it include it? Yep, maybe I included it somewhere. Wait, what was the error? Yeah, message. Looks like I have included it inside scheduler. Where did I include it? I guess it's scheduler.h. Let's just fucking remove it. And this. Okay. We can deal with that part later. Okay, what do we have here? We have K-main that is trying to read some fucking thing. Okay, I did try to implement these parts. Okay, we can do that later. We can do this later. I did not know. Now we can run it. And we are stuck. Let's just see what was the error. Probably it's camo. Okay. And we have error at 4008. That's exactly what we tried to add, and we still got an error. So maybe we did not add it properly. I just remembered it because you're not supposed to read directly from that, because we have a DDB base is from now on is a virtual base. So let's just say, what is this? I don't know. Maybe it's a helper. I just have to change this with virtual DDB base. Should work. At least if my scheduling, if my MMU works, then it will work. If it doesn't work, it will fuck me up. That's all. For get RAM, let it be just DTB base. For here, I can just read it from virtual DTB base. And let's try now. Okay, we still have a fucking error. What are we trying to read? Why the fuck are we trying to read from 4040? Didn't we just say that every damn thing should be from DTB base? Okay. I also have fucking things here. So I guess the thing worked, because looks like we moved past some bytes. Okay, let's try it again. Okay, so it is working. Now let's just see what it has returned. And what the fuck did it return? What the fuck did it return? We're here, we're here, we're here, we're here, we're here. That's my fucking function. Today. Oh, I just wrote it. Maybe I moved it to init. Okay. I called it inside init. Okay. I should not call it inside init. I should be calling it right after. I guess here. And just put while true. Oh, this thing should work. And we'll put. Okay, that should be good. And let's try to print. You are printf, our own fucking printf results. And yell, comma, yell, comma, yell, comma, yell, and comma, yell. Okay. Let's see. Yeah, I have to respond. Sorry. Let's just put drive info. Or maybe it should be easier if we just put I and put for I int I equals 0, I less than 5, I plus I, and put this and put this inside. Now let's see. Okay, we have something. We have an address. We have, okay, let's see, HTML2. Okay, so it starts from A00. Oh, fuck me. This A00 address, I guess I used it somewhere. I don't remember. I remember using it. No, I used it from virtual space. Yeah. This is this memory mapped actual location. I think so because I feel like I used it somewhere. We could just search A0. Okay, that's 8A0. So we are safe. It's just A00. Okay. So we have the address and we have the total. We have the address and we have the total bytes. Oh, the address range, and we have 3 empty zero values. That does not seem good. Let's try. Maybe our fucking extra work just fucked us up. Let's see. We have reg works just fine. And let's get total. Okay. We have which that works. And then we get into reg that also seems to be working fine. And then we have the actual I. Okay, this is why we fucked up. It's INT. Okay, that's fucked up. Now I have wrong values. Wait a minute. Wait. How many things am I? 1, 2, and 3, 4, 5. Wait. Oh, that's why it should be 2 and 3 and 4. And here I'm supposed to just 5. Okay. Okay, so for some reason we are able to read the interrupt number and the results, but I'm not able to read the first two values. Maybe there's some random bug, so it's alignment issue probably, because sometimes it works, sometimes it doesn't. Wait. Let's put 6 and try it. Okay, we still don't have that. What can we do? Okay, actually, because we are inside the kernel, we could just use print messages from now on. Let's just copy paste, and we can go here, and let's see. Okay, let's also try to paste it here and see fetch IO, and it's a string, so we put string and we use that. Okay, now we run it, and we have to include what, so we come here. Okay, we copy that and we paste it here. I think it needs standard args. I don't know, but let's try. Why it did not print anything? That's so fucking sad. Wait. We're inside. We were never inside Virchayo, Reg. Why is that? But we were inside this. Virchayo. What is this? Interrupts. This is which IO register. Now let's run it. Okay, so we are inside interrupts, that's why we were able to get this. Okay. But we were never inside the reg for some reason. How is that possible? Maybe we can also just print the string then. Current string. It's all possible because we are inside this. If we were to call it in the start, we would not be able to debug it like this. We would have had one hell of a time. And we have interrupt, parent, blah blah. We do have reg, reg, 0, 1 and 2, and why the fuck it did not? And we never went into register? Why? We are here and we know that it's a register, but it says we are not inside Virchayo. I think we'll have to print the name too. What printer name and string its name. Let's see what we get. Okay, we have empty name and we have these and we have PSCA and we have this and we have it. We have memory and it's 4000 and it's reg and device type. And we have which IO and it does not have a register. Okay, probably LLM fucked us. Okay, so maybe it's memory, but it does not have a device. It only has device type and reg. Where's a fucking thing? I guess we might have to actually write a real parser because it says that if we want to read these things, we also need to read the address cells, those size, stuff like that, because those values are inside the top and we do have those values. But a minute ago it was working because I did see something there. And then all of a sudden it was not there. It's just so fucking annoying. Does not have any reg. Does not have any reg. Oh fuck. Okay. We have a new issue. Right now we are not able to tell why the fuck we have initialized it and we have set it as drive. Wait, let's just check drive flag. What the fuck is drive? We have defined it as virtio. And format as raw. Maybe we can remove format and it will automatically try to interpret it and make it better. There's nothing else here. How to reach this drive from ARM. DTD. I want to use an ext4 image. Okay, but how do I access this during kernel booting? That is find IO through DTD. You piece of shit, I don't have any kernel. I am in boot startup and parsing DTD. I want to read this drive. Parse the DTB, find nodes that compatible with, get the physical address of you fucking moron. Comfortable equal to virchaio. Do we have anything like that? Okay, we do have one. Maybe we are stopping here. Wait. That's why we are fucked up. Next thing is no longer prop. That's why we went out of it. That's why we set inside is equal to 0. So this is valid. I'm just wondering why the fuck it does not. It does reach this and then I get fucked up. Let's try one thing. Let's fucking remove this. Let's see. Let's see what happens. See, now it's working. Now we reach the interrupts and then we reach the reg. So probably my fucking instruction is wrong, so we are getting some error or whatever that is happening there. This is we read 4 bytes and we push back, and we read 4 bytes and we push back. Is this what is fucking up? Let's run it. Yes, this is what is fucking us. Maybe we should not always we are inside virtual interrupts. Okay, we're inside virtual interrupts, and from what I remember there should be 3 values. Maybe there's only 2 values. There is type, and let's remove edge. Type and num. And let's see what happens now. The first thing that we read is the 16th. So I think this is the num. First one is the num. Just cut it, paste it. First one is the num and second one is the type, and then what else? I think this we should break. Should not but fucking continue. Now I have to figure out why the fuck reg is not working. Maybe this fucking thing is this. How the fuck? There's only 2 fucking things that it can do. It doesn't do anything else. And if I just remove that, my fucking thing works. That's just so fucking annoying. I think I'm just going to remove it one block at a time. It's num, right? Let's remove num and as soon as I put that, it's fucking fucked up. Because I come here and I read 32. Maybe registers are just 16 bytes, so we should not read 32 bytes out of it. How is the size of this total block? Property contains 32 bits. So it's 12 bits of 4 bytes. Okay. So it is 32-bit cells. But I don't have, if I read that, the fucking whole thing is messed up. If I don't read it, if I just don't read it, then it's working. If I read 32 bits out of it, do I really need the interrupt number? I am inside the reg. And I have the length. Okay, maybe if we get the length, we should get something. Length. Let's see what's the length of that. Length is 12. Okay. It's not even 132 bits. It's just 12 bytes. No. So I should not read 32 here. Okay, read 12. Have to read 12 bytes. There's 1, 2, and 3, 4. 4, 3, so 12, 4, 3, 4, 4, 4. Okay. Maybe then I just take one character at a time. Okay, then read 32. We read 12 bytes. Int 32. Interrupt 32. So we push the 24th bit to 0. No, we push the we push the 0th bit to I fucking don't understand. Wait, let's picture it 0x. Let's say the final bit is 808. No, bytes 8. And then we have, say, A. And then we have, say, 1. And we should have 0 here. But 24 to 32. Zero, and then 8th to 16th, and 16th to 24. I fucking have no clue how to convert this mapping, because it's in Little Indian. We have to switch it. That's what I'm fucking doing here. That I get it, but I don't understand, because those are bytes, and because they are laid out in some other format, we switch it back to the original format. So we move the 0th to 4th, and third to second, something like that, and second to third, and zeroth to fourth. This is what we are doing here. And currently we have to read 3 bytes. Now how will I shift it? I have to shift the 0th bit to 24 to 16. Maybe third bit to first, and first bit to first bit stays in the first bit, and the 0th bit to third, something like that. Well, let's try this. Let's see what happens. No harm in trying. But I still don't exactly remember or understand what it is. And we move 3 bytes. Okay, let's try now. And we don't have anything. Drops is 12. I have to increment it by 3. That is correct. But if I increment it by just 1, what happened then? And if I increment it by 0, then it will work. Fuck me. How was that? So I should not increment it at all. So interrupt has no value in it because it says it has a length of length of 12. So it does have 12 bytes there, and then we have the string. and we have int and we don't need this step, and we have read, which is going to try to read something. Wait, if we increment it by 3, don't read it here, what happens? Fuck it, wait. Oh, it increments it by the length. Finally. Then why should I move P with 3? Because it's anyway gonna take the length and increment it with length. Then what's the point? Okay. So thing is, previously I was hard coding it. So once I reached this point, I wanted to return. So I manually updated the p values here. And I know that after this point I'll never go further, so I could just return there. But here, because we have to go past it, if I increment the value here and then increment again the p with length, maybe it will just not work. So all I have to do is read this and not read this. Convert it into number, put it in the thirds. Now what? Let's see what happens. But I get 0 here. That is not good. It's already 2 hours. Okay, I have 5 minutes. Let me at least try to fix this one part. I'm inside interrupts first, and then I'm inside reg. all I have to do is UART printf, and it's going to try, let's say D, with P of 0. Let's try P of 0 first. P of 0, 1 is 0, 2, 1. One is also 0, 2, 2 is also 0. Do I have character? Let's try character. Okay, fuck it. It's full of zeros. That's why we are just seeing zeros. I don't know. Well, we have to go to the other approach now. We disassemble, read, interrupts 32. At least here we should get some idea of what the fuck is happening. Wait. It should be x0. This is our address. Let's read 10 from here. And we have A00 here. Wait. Is this my interrupt? And registers are here. Interrupts are here. I think that is it, because this is the next line that is we are going to parse. Here we would be parsing these three values, and we have nothing here. Wait, let's put minus x 10. And and our string is interrupts, right? Okay, it's interrupts as a string will be in there, but we have a E 12, 13, 14, 15, E, F, A, B, C, D, E, 13 and 14, F. Okay, yeah, this is C as in the 12 bytes that we read, and probably this is the index within the string. This is the length, this is the index within the string field, and this is the value, and this is again the length, which is 1x, and again this is the index within it, and it goes on and on like that. So this is the actual value, and it is 0. Maybe there is no interrupts to handle, probably. I don't know. Is it possible to have 0? Interrupts block is 0 in for which IO. Or I just fucking parsing it wrong. Okay. I think at this point, let's just assume that interrupt is 16 and think about it later. But at least we were able to parse the address. That's the only thing we were able to parse. And the thing, but we were not able to parse the registers. Maybe there's no interrupts. Well, we can think about it later. And now let's just say that we have do you have the handled interrupts from devices? Like IRQs. What will be the implementation? What will be implemented inside that? So after we register event into which IO queue, we will get an interrupt to notify us that the event is processed. Example, block read is done. Okay, so we have to how do I confirm this? Okay guys, it's going to take a lot of time, so let's just assume that we'll have the setup next time, or at least this time we were able to get the address properly. Next time let's try to fix that interrupt and read the interrupts properly. And thank you. Have a good day. Bye.